Hello, I'm Roshan, recording assignment for Design Patterns Lab. So this is the design pattern I took. It's called Memento. Let's look into it. The definition says without violating encapsulation, capture and externalize an object's internal state so that the object can be restored to the state is the purpose of this design pattern. So Memento is basically a design patterns that saves the successful state of a program or a machine so that later in case of an error or when required you can restore that saved state uh, to avoid any issues. So let's look into the summary first. So the summary says the memento pattern provides temporary storage as well as restoration of an object. The mechanism in which you store an object state depends on the required duration of persistence, which may vary. So persistence talks about how long or um, for how much time or what are the variables that affect the storage of state. So it varies like on different scenarios. Some maybe when the next successful state occurs you change the previously stored state, and otherwise sometimes you can even explicitly force uh, a particular state to be stored. And the next para is you could view a database as an implementation of a memento design pattern in which objects are persisted and restored. However, the most common reason for using this design pattern is to capture a snapshot of an object state so that any subsequent changes can be undone easily if necessary. Um, Essentially, a memento is a small repository that stores object state. Scenarios in which you may want to restore an object into a state that existed previously include saving and restoring the state of a player in a computer game or implementation of an undo operation in a database. Here they talk about when is this memento design pattern used. Uh, Basically, it's storing a previous state of an object. It is mostly used in video games, databases, undo operations, etc. The application actually I'm doing is database. So in video games, let's say we have saved some checkpoint so that even if we do some errors in one, we could go back to the previous saved checkpoint. So Memento is a design pattern that is being used there. Even in an undo operation, you can actually store a series if you want. You can actually store a series of save points, that is mementos, so that you could even choose which one to which point you want to go back to. Even the Windows backup system works on based on this software. They say a particular restore point so that in case of any failure of the system, they can go back to that point. And this is the diagram. So as you can see, there are three classes you hear, three objects basically. So one is originator, one is memento, and one is caretaker. So we'll look into the next one so you can understand it clearly. So these are basically the participants, originator, memento, and caretaker. So what they do is memento stores internal data of object or originator object. The state can include any number of state variables. So originator is what about what we is the object about what we have to store the state on. Like let's say it's a game, so game is the originator there, like a game's progress is the originator there. So a particular state is a memento. uh, so a originator creates a memento object. So a memento is always of the type in which the originator is defined. And it is a memento object is to restore to its previous state. Now another participant is a caretaker. So caretaker responsible for keeping the memento, and memento is opaque to caretaker, and the caretaker must not operate on it. What they say is there might be a number of mementos. So what caretaker is the object that handles all these mementos. It stores them, organizes them, and also make sure that no one can change the mementos that is being stored. And it is we can read from it but not change any values on it. Now if you look at the diagram, now you can understand there are a few functions like Originator has set memento or create memento. Create memento is used to create a new memento or to save a new state. And set memento is to assign values to each variables or attributes. And memento object itself has few functions like get state and set state. So get state is to get the particular state of that memento, and set state is to set values in the state of that memento. Now the application. So our application is database transaction. Uh, a transaction is simply one operation that is performed in a database engine or a database management system. It can be further divided. Uh, so the definition is database transactions are operations on database that occur in atomic, consistent, durable, and isolated fashion. A transaction can have multiple operations on a database. Each operation can succeed or fail. However, a transaction guarantees that if all operations succeed, the transaction would commit and would be final. So if the instruction that is being executed is successful, we would commit, that is save that particular point and give it to the caretaker. Now if any operation fails, then the transaction would fail and all operations would roll back and leave the database as if nothing has happened. So let's see how it actually works, the implementation on it. So the mechanism of rollback is like, let's say we are doing some operation on a table. So before doing the operation, the database engine takes a memento on that table and saves it, like keeps it on one side. So even if the operation that we are doing on the table is not successful, we would use the memento and revert the table back to its previous state. So what the percentage says is, consider an object representing a database table. A transaction manager object which is responsible for performing transactions must perform operations on the table object, which while having the ability to undo operations if it fails, or if any operation on any object, any table object fails. To be able to roll back, the transaction manager object would ask the table object for a memento before performing an operation, and thus in case of failure the memento object would be used to restore the table to its previous state. Now before looking at the consequences, I would like to show you an implementation of it. So uh, yeah, this is a sample code of a memento in JavaScript. So person is a class in JavaScript, and this is actually the originator class. So it has attributes like name, street address, city, and state. That is the address and name of the person. And it also has functions like hydrate and dehydrate. Hydrate is used to save a state, like to create a memento, and dehydrate is used to generate uh, generate a person object from a memento. Now caretaker is used to store uh, the mementos that is being generated, and to add a memento into the caretaker object, you have the add function, and to retrieve it you have the get function. So let's look into the code, and first let's there are two objects of person class, that is Mike and John. So we have the name Mike Foley and John Wang, and the address of all of them. Now we make a variable for the creator class. First what we do is we save the state. So we call the hydrate add function first. In the add function we pass two values, and one is a number, it's a constant, and another one is the function called mic.hydrate. So let's see what the hydrate function do. The hydrate function, it takes all the states of a variable and put them in a string and stores it as a memento. So here we already have all the information, that is this. Now it is all being converted into a string and it's being stored on a variable named memento, and that is being written here. So that is received by the add function. Now add function takes a key and the memento. The memento is stored in the array named mementos, and the index of that particular memento is the variable first argument pass, that is 1. Now the second argument, that is the second element of this array, will be the memento on the variable John. After that we are simply modifying the name in both the variables Mike and John of person class. So Mike Foley is changed to King Kong and John Wang is changed to Superman. So this actually changes the value stored here, but now we want to revert it back. So what we do is we use the dehydrate function. So the dehydrate function first needs a memento to revert it back to the previous state. So let's see, to get the memento it uses the get class of the caretaker, get function of the caretaker class. So it gets to know what memento to get, you pass the attribute of that memento. So first we know we store the Mike's memento in attribute 1, so we call in element 1, so we pass that as an argument when we retrieve the memento in element 1, and we dehydrate it, that is we take it, we pass it, and from that pass we take values of name, state, city and state and give it to the attributes. Now we are actually reverting Mike and John back to its previous state from its memento. So if you want to there is a log class which keeps track of all the operations that is being performed. Now if you run the code, you can see that Mike, Folly and John, which was changed to King Kong and Superman, is reverted back to its previous state by using the dehydrate function. So that is this. And if you look into the consequences of this, uh, Momento protects encapsulation, avoid exposing originator's internal state and implementation. It also simplifies originator's code such that the operator does not keep track of previous states, since it is responsible. This is the responsibility of the caretaker. So encapsulation is it makes sure that object state and property stays together, uh, and it also makes sure that a memento that is being stored is not being manipulated. That is, the state has to remain as it was while it was successfully executed. And the second point is using the pattern can be expensive depending on the amount of amount of state information that has to be stored inside the memento object. In addition, the caretaker must contain additional logic to be able to manage mementos. So mementos, um, it actually induces an overhead in storing every time, like every time when a instruction or a transaction is successful, it needs to store or update the memento that is being stored in the like with the caretaker. This always, induces an overhead. And also, to write a code for a caretaker, it is again, uh, in one way it reduces the code, as we don't have to add uh, individual features for um, preserving previous state in every originators. So a caretaker alone can say a lot of mm, code writing, but it also induces another logic that has to be cracked later in the program. That is all. Thank you.